Hello and welcome to Technical Utkranti. In this fifth lecture of the series of C programming, we will see preprocessor directives. In the last video, we saw declaration and definition of functions and variables and how is it linked to memory allocation. We saw then function prototyping and what is its significance, and then lastly we saw main function and its two types, one without arguments and one with arguments. Today we'll understand what are preprocessor directives. For now, just keep in mind that anything that starts with hashtag in the code is a preprocessor directive. We'll follow the following sequence in understanding the preprocessor directives, which is understanding the relative comparison of variable, constant, literal and a preprocessor macro, and then we'll delve a bit deeper into preprocessor macros or directives. Firstly, understanding the meaning. Variable is a piece of memory which the user can read and write multiple times. Constant is a piece of memory which the user can initialize and then read multiple times, but the user cannot write on it further. Literal is a value. Wherever a number is used in the code, that number is basically a literal. And what is preprocessor macro? So, as the name suggests, something which is happening pre to the actual process of the compilation. So, the actual process of compilation has its first stage as pre-processing, and during pre-processing some replacements happen. These replacements are nothing but macros. So, how you define these different data containers in the code? The data type and the name of the variable will be how you define a variable. If you add a const keyword to it, it becomes a constant. As already said, literal is just a number, and a preprocessor macro is defined by the keyword hash define. So, hash define num10 will replace num with the value of with the value 10 everywhere in the code. Okay. Now, memory accessibility. So, using a pointer, a variable could be read and write as shown in this green block here. For a constant, if you use a pointer, you can read that memory location where a constant is stored, but you cannot write on it anyways. So, memory accessibility only in terms of read is there. For a preprocessor macro, there is nothing as memory allocation. It is just a replacement at the first stage of compilation. So, there is nothing called num in the actual source code. Okay. So, there is no point of memory accessibility. So, now we will look into what are preprocessor macros. So, preprocessor macros could be a number replacement or a logic replacement. We will understand it with the help of an example. And just remove everything else. Yes. So, let us see what happens after I execute a preprocessing command. Here, the replacement of whatever that was written over here has been happened. Num 1, 2, 3 have been replaced, and this some logic also have been replaced. So, that's how macro replacement works. Now, this code will further go for compilation. Macro expansion happens with this command filename.c to filename.i, as we have already seen. Another thing which I would like to show you is that instead of defining the macros over here, we can define it in a separate file over here, and using the preprocessor directive hash include hello.c, we can have the same effect as it was previous. Macros will not work. So macros will not work for recursion. Why is it like that? So what is recursion? Recursion is when a function calls itself. For example, we'll see a recursion function in use would work. Okay, again I have to give a number. Sorry for that. Yeah, so it is able to print it 5040. So this is an example of a recursive function. Now if I want to implement the similar thing using a macro, will I be able to do that? Let's try it out. I remove this, I remove this. For the time being I remove this, even remove this. Fine. Now I had defined it, just for the time being I defined it n into factorial of n minus 1. So let's see what the pre-processed output looks like. So as you can see, the pre-processing has replaced it with 7 into factorial of 7 minus 1, which is 6. It has not further replaced the factorial of 6 as 6 into factorial of 5, because macro replacement is an inline replacement, which means that each line would be replaced just once, and it will not be like, okay, again recursively replacing in the same line. And by the way, 2 semicolons have come because one semicolon was over here and another semicolon was here. So I'll remove this one and it will be okay. Yeah, fine. So this recursion thing will not work. Another important thing which I missed out previously was that you can write bigger macros using this backslash thing. Okay, so I wanted to write, if I had wanted, I could have written it here only like that, but let's suppose I want to write it in another line, I would have to use this thing like that. Okay, fine. Moving ahead, we'll see now different varieties of macros. So now there are conditional preprocessors. These conditional preprocessors helps in compiling the code in a conditioned way, right? So let's see some example of it. For that, I'll just include the standard input output library once again, because I would be needing the printing utility. Remove this, and let's suppose I just have printf happy birthday, right? And now I print it only in a conditioned way. So if num greater than 10, have this line in code, end if, right? So for that I'll just define a macro hash define num as, okay, 12, let's suppose, and let's compile this. So it is printing happy birthday. Okay. Now if I define num little less than 8, what will happen? It is not printing it anything. Why is it like that? We'll see what is a pre-processed output for such a thing. So we see that over here it is no more existing, the printf function is no more existing only, because that will be there only when this num is greater than 10, which is defined as 8, right? So that is one thing. You can also define num using this flag, and the value would be coming from the command line itself rather than the code, right? Okay, let's move ahead. What are pragmas? Pragmas are compile time instructions. For example, if you don't want the programmer to use a particular utility after a certain line, you can poison it. Okay, so how does it work? We'll copy paste it and use it in code. I'll remove this. Okay, so now I'm saying that the programmer cannot use printf after this. Let's see what will happen if I still adamant of using it. Will give me an error. Okay, and if I have this particular line of code where I am using printf above this pragma, then I'll surpass this particular error, right? So this is done to ensure that something is not done after a particular statement in the code. Okay, let's move ahead and see another class of macros preprocessor directives. So hashtag error and hashtag warning. In a particular part of code, if you want to print a warning or an error, once the compilation or the code flow reaches there, you can have that also. So again, I will use the similar example. Hashtag if num is less than 10, hashtag end if. So here I can give a warning, the number is less than 10. So during the compilation itself, I'll get this warning here. Okay, so you can use this utility if you want the warnings to come up in certain conditions. Similarly, that error preprocessor directive can also be used. Similarly, this undef will undefine the macro. So for example, I have hash define num as 8, and I can use hashtag undef num. Okay, so here if I want to use num, so for example, I want to print the value %d, what will happen? Okay, it has given me an error that you are using something which is not defined only, and if I just comment out this line, then it will not give me an error, right? So it is able to print it. Another example, another use case is that I undefine it and then I have a variable of a similar type. So if I want to use in a piece of code, I want to use the same thing as the preprocessor macro and the same name as a variable, then I can undefine it, and then after using it as a variable, I can again define it like that. So yeah, yes, so these were few macros, and to summarize it, what we understood today is the different data holders and the and their differences and similarity. For a preprocessor macros, their entire role is at the pre-processing stage, where they act as a replacement. Okay, so they result in replacement in the source code, and then that source code, the replaced source code, goes for further compilation. Okay, and then we looked into the example of macros usage. So that's it for today. Hit like as it motivates me to make further videos. Thank you.